As you may have already guessed, I have been actually motivated or actually implied by Mr. Toda to get on this journey of explaining about the cost overrun, how to prevent the cost overrun. My daily life is nothing to do with it. I am the head of the energy forecasting group. I am doing the working with econometric experts and engineering modeling experts, including the power generation model, etc. And yet, I have been working with Toda-san since, I don't know, back in 2018 or 19, before the COVID. So I have been to all the Baltic countries, and I have been to Poland back in 2020. So I was very happy to hear back from Toda-san, but this one is really out of my expertise, so please bear with me. I will go slow, because I learned a lot by researching on this topic, and I am very much impressed. First of all, I would like to congratulate the people of Estonia for your Independence Day yesterday. Congratulations. And then I would like to congratulate on your decision to explore this path of developing nuclear. That is actually, as my previous speaker said, it's a century-long journey. And then it seems, so far, what I have heard, you have been stepping into the journey with the very good companies, the international institutions or governments of many other countries who have experienced the goods and the bads of the nuclear development. So I wish you a very good journey, and I hope my small presentation will give you some hints on that. So I hope this will. Good. I will talk again about the status of a Japanese energy policy, nuclear policy, but that will be brief because Mr. Kawamura has thoroughly explained that. And then I will also try to cover, sorry, I can't see it. Cover the code of action for the innovative reactor development, which is also a part of the Japanese nuclear policy, which was not necessarily mentioned. And then I will get into this very major topic of cost overrun analysis, which is done by many international organizations. Sorry, I have to look the notes. Then at the beginning, I will talk about the Japanese policies. As you may be already aware, Japan has already submitted the NDC, the new NDC, to the IPCC, and that is to be targeting the carbon neutrality by 2050. And then we are actually on track up to the 2023, which is the latest, the real number we have for the moment. And you can see the red line is a kind of trend line aiming at the 2050 carbon neutrality. And you can see that the 2023 number up to 2023 also, but it is on track. But that was actually by luck or by unluck, because the industrial activity was not very good. So the economy was suffering, therefore the energy consumption was low. That actually very much helped, but we observed that the household energy consumption was actually going up, and therefore the CO2 emission related to the household was actually bigger than what we expected. The energy consumption effort, energy conservation effort is actually not as much as we hoped. That we can see for the transportation sector and then the commercial sector and the industrial sector. Sooner or later, they may face the similar issue if we keep on going that way. But actually, this plan is expecting the more, the radical effort in energy conservation. And then we are seeing the other reality, which I will show again, like Mr. Kawamura. But at the moment, this is the official plan for us. Therefore, the 7th Strategic Energy Plan is based on this target, and then we are hoping that we will meet the target and then going forward up to 2040. So Mr. Kawamura said that 20% of electricity production will be supplied by the nuclear is the target. Remember that number. Well, just to catch up with the general notion of how to meet the energy, the carbon neutrality. First, save the energy, which is required to do your daily activity, economic or social activity. Try to economize as much as possible. Maybe you come up with a more efficient way of using energy to make what you want to do happen. And then try to electrify as much as possible and then make that electricity generation as clean as possible. That has been what Japanese government has been aiming at also. But then if there is any remaining use of fossil fuels, there will be a CO2 emission. Therefore, try to develop the CCS technology as fast as possible, and then try to address that. And yet still there is an emission in the air, then you try to address that by directly catching. It's called the direct CO2 emission. How do I say catch? How do you call it? The direct to DACCS. I forgot temporarily the wording in. No, it is a direct air catch. It catches the CO2 from the air directly. It's a very small amount because it's very tiny, thinly spread the air, the CO2 in the air. But there is a technology, and then many companies are actually developing that. But anyway, with all these technologies, we try to address the carbon neutrality. But of course, one thing or another goes wrong. And then one of the things for us has been the hiccup with the nuclear. Even though renewable electricity and nuclear energy electricity are hand in hand, should be hand in hand for as a clean electricity, but we had a hiccup after Fukushima that while the nuclear, it has to be decommissioned, and if it's decommissioned, we don't construct any new nuclear. That was what we had up until the previous basic energy strategy, because there was a political atmosphere, and then the people in the public were really against to have the nuclear keep on going with the nuclear. Some people believe, listening to the NGO very carefully, that the renewable energy electricity is good enough to supply 100% of clean electricity. But reality is not. And then we also have the added reality, which we heard already from Kawamura-san. It is that. This is the forecast or outlook of energy demand into the future, 10 years of the future, which is announced every year from the organization, which is it's called Cross-Regional Coordination of Transmission Operators. So it's a gathering of the transmission operators, and then they are responsible to match the supply and demand of electricity. And then this one is revised every year in January. And then they have been estimating the dotted line, the blue dotted line, like up until January of 2023, that it is going downwards into the future, just as the government wanted in planning to meet the carbon neutrality. But then 2024, surprise, surprise, orange line, it suddenly go upward trend. And then it was even go more upward this year in January. And then this is happening in many other countries, including United States. So Texas is the very typical case, but then not only in the United States, European countries are equally concerned about that. And then that is caused by, well, it's not our enemy number one, but caused by the new power demand from the data centers and also semiconductor factories. Putting the semiconductor factories is a good thing for the industrial policy. We are going to have the new industry in town, and yet they need electricity, and then they need quality electricity. electricity with good quality. It is stable, and then possibly it is supplied 24/7. Well, if you remember, what is the valuable renewable electricity? It is the intermittency. When the wind winds, it's good. When the sun shines, it's good. But the sun doesn't shine at night in any country. Therefore, asking for 24. So thank you for for your reactions. The 24/7 cannot be expected from the solar power, and then Japan is famous for having a very good capacity of solar power in the world. We have the same land space as Germany, but we don't. We have almost half the flat land space as Germany, but we have twice as much capacity in comparison to Germany in photovoltaic. That means that we have already exhausted the ideal space for the mega solars. But anyway, we have a lot of mega solar, and then we are trying to establish the wind power, the offshore wind powers. But as you know, also in the European experience, that it's becoming very costly. The cost inflation is attacking the wind power. Therefore, it is also very difficult, and the wind sometimes doesn't blow. Therefore, it was actually last push for the Japanese government to go into this new journey of we need nuclear also. It was first pushed by the energy crisis, as some of your colleagues have already mentioned, that it hit Europe very severely because of the wind didn't blow in Spain, England, and maybe Germany. Back in 2021 winter. And then the Russian invasion to Ukraine happened. So all globally, we suffered from the shortage of the natural gas, which was better than nothing, least CO2 emitting fossil fuels, which is very convenient to start up and then burn gas to supply electricity in terms of emergency, like when the wind doesn't blow. And we intentionally stopped the use of the Russian gas. So it pushed the government first. Oh yes, of course, energy security. We need to supply electricity to the people at the reasonable cost, economic efficiency, and at the same time you have to meet the environmental target. Then the gas is the least emitting the fossil fuel, so we should go for gas, but it's expensive. Economic efficiency is jeopardized, and by the way, we have nuclear. So the nuclear is pushed by several different factors to be back on the stage for Japan. Well, this is what is already explained by the Kawamura-san, but I wanted to answer the question by adding some factors I thought which was important. And then that was, I have already explained, the three major the factors, that the valuable renewable electricities are the intermittent. Therefore, they cannot serve the increased the electricity demand, which comes from the data center, which requires us 24/7 services. And then secondly, the energy security concern. And then thirdly, it is because the renewables and the nuclears are not the enemy to each other, black and white, or they have to work together. So we have started our own journey to restart the acceleration of the restart of the nuclear, as well as to develop the new reactors, which is the advanced technologies, advanced light water reactors, and then that will be the one I will have back in my mind, that we are together. So this is the government drawing, which says that we have to maximize the existing reactors. Therefore, the lifetime is also the extended, but it's not enough. If you look at the dark part, that is reactors which is already approved to extend the service life to 60 years. This is omitting the extra extension, but then it is still going down drastically in capacity, and then that is also reaching zero before 2050. But although we are talking about carbon neutrality by 2050, we are not talking about that's the end of our story. We have to go beyond the 2050, still supplying electricity to the people, and it has to be clean. Therefore, that gives us the idea that we need this upward the arrow. The next generation reactors, development of a next generation reactor is important. That is why we have some roadmaps, and then we have some guidelines. And this is the guidelines for action for the nuclear before we all agreed that we can actually step into the new journey with the nuclear. This was to actually to explore if we are to keep the nuclear, what are important. And then that is the restart is important, accelerate that effort is important. We keep exploring the possibility of the developing the technologies for the advanced nuclear reactors is important, but don't forget the how to close, how to decommission the reactors, and then how to actually reutilize the fuel, and then also how to maintain the supply chain, because we are, as it was mentioned, that we used to have 54 before the earthquake, and now we have 14 in operation and 12 more to come. But it's kind of diminishing industries, and then how to revive the industry and then supply chain is also another issue which is common with the advanced countries, and then we share that issue. It's very important. And then, therefore, we are here to contribute to the common, to address the common challenges with the international society. This is about the how we go about having had the seventh, the new energy strategy, basic energy strategy. We haven't started discussion yet how to address this. We don't have any roadmap. When it will be roadmap, I mean the concrete plan for the new nuclear reactor, and yet those are the things we have to care about, including the supply chain. We need a clear plan into the future so that the industry or related to suppliers or vendors or all the stakeholders should be aware that that is what we are aiming at. And then I envy Estonia. You already have some plan started. We have to start making that. But government is still very cautious of stating any number. Unfortunately, it is still sensitive topic for us in Japan. Therefore, we are aware that it should be done, but we don't know yet how to go about. So maybe we are a step behind you. This is the roadmap, which is a very general roadmap. It was made September 2020, announced September 2022. Therefore, it is far before the current, the new seventh basic energy plan strategy was decided. So it was, even though we don't know how we go about with the nuclear, we keep making the plan or roadmap so that we don't extinguish the fire we have. And then these are the type of reactors we are considering. The very first comer will be the advanced light water reactors, and then that has many good signs, yellow mark, the technological maturity is there because it is the fourth generation reactors with the safety, more safe technologies, and compatibility of standards is also good because that is the extension or the next generation of the currently popular reactors we have in Japan, so the regulatory standard is good. The supply chain good in how to say, good in general, but there are some specification which is requiring special attention. And the supply chain is also good because we used to have a very good industrial community, so we can restart. We are not without any base. We do have base, and that is good news. And economy is also good. It is not extremely more expensive than the current technologies. This hydrogen production is not, it's a quizzical yet. It's more for the fast reactors or high temperature gas cooled reactors because they are good at generating the high temperature the steam, and it is good for making hydrogen or also to serve the industrial sector. I didn't mention, but there are two difficult sectors to address in meeting the carbon neutrality. One is industrial sector, especially the manufacturing sector with the high temperature usage, and another is the transport sector. Even though people talk about electric vehicles will solve everything, but it's not. We have the shipping, we have the something flying in the air, and then they have to have more options. And then this hydrogen is one of the options. The shipping is actually looking into the alcohol base, the how to say, ammonia fuel. For example, or even the hydrogen. Therefore, we have the option of first reactors and high temperature reactors, especially for the recycle of the fuel. We also need the fast reactor. Nuclear fusion, yeah, of course, and we are involved in that. And small module reactor, as you know, Japan is a very big company with a lot of electricity demand. Therefore, the small module reactor is not our first choice because then we have to build many small module reactors. And that is more complicated than make one big light water reactor. Therefore, we don't have an immediate plan to go with the small modulars, but we keep on exploring, or we keep on joining the programs abroad, so that we will have the technologies available once we are ready, our country is ready to take that option. These are the explanations, and then I believe that the slide will become available later, so this is just for your reference. And this is the roadmap which Kawamura-san also mentioned, I think. And then this is also prepared before the seventh energy strategic basic energy plan strategy. Therefore, it is just a kind of having some idea because it's always nice to have the roadmap shared by the stakeholders. So it was developed by the working group, and then this is something which have at the moment. And of course, it's subject to the agreement or permission or agreement from the local community and municipal government. And currently, we have this advanced light water reactor as the priority to develop. And then the Mitsubishi MHI SRZ 1200 is the leader. But of course, other the vendors like Hitachi GE or Toshiba have their own the technologies. To be fair, they are kind of competing each other. And yet they share the information when it's necessary, and then I will mention that next. We do have an association called the Atomic Energy Association, which is actually the gathering of all the nuclear industries together, and then they have collaboration with the safety, Japan Atomic Safety Institute, the JANSI. It doesn't work. JANSI, the left-hand side down, the orange thing, is a institution developed after the Fukushima, and then they are specialized in understanding the safety measures and then understanding how to develop our safety measures even further, depending on the circumstance. And then that is involving the CEOs of the power utilities, and then they get together regularly to share the knowledge, and then they visit each other and then exercise the safety measures together. And then JANSI, with collaboration with Athena, and then there is a research hands, and then they are also in collaboration. And then they are concerned that if we are to develop the new advanced technologies, if the safety standards, the regulatory standard is compatible with the new technology, therefore they are starting the discussion, the dialogue with the regulatory board. And that is very important, even though the advanced light water reactor is the how to say, the baby from the current light water reactors, but technology is different, slightly different. The more strengthened safety measures, like a core catcher, etc., and it has more autonomous safety measures, like secondary power to be supplied in case of emergency. Therefore, the current strengthened regulatory standard may not meet what they are developing. It is maybe over-regulating the next generation reactor, which will be already ready to be safer. Therefore, and then that kind of incompatibility or difference in the good regulation for the current technology may not be over-regulating and then more cost adding matter. Therefore, the Athena is there to have the regular dialogue with the regulatory board, and then the regulatory board has already agreed to join them from time to time for this technical discussion. They are creating I think it is called working group, and then the dialogue will continue, and then it will be reported to the regulatory board's the regular meeting as what has been discussed and what has been discovered, so that the regulatory board will be aware of the issue the suppliers have concern of themselves. So it is a kind of a first attempt to do the dialogue over the technologies on the technical level. This is for you to read later, because it is also the repetition of what I have said. But it is just started last year, and then I hope that we will hear more about it at the end of this year. Another thing the government has developed is actually the bidding system. In Japan, as in many European countries, there are many thermal power plants have retired, while the nuclear power is kind of smaller in the number, and then it is slow in restarting. Therefore, we are concerned that there won't be any new installation of any power supply into the future. In order to supply the construction, the fixed cost, the government has developed the auction system where the utilities which are planning to install the new power station, or even to add the safety measures to the existing nuclear power, they can bid for it, and then if they are endorsed, they can actually expect 20 years of income after the start of the operation. So this kind of long-term the income to be given for the fixed cost is introduced. But of course, there are many says from the industry. It's not good enough for the industries to clear the uncertainty of their operation, because there might be the cost inflation, there might be the other circumstances which may change, but at the time of the bidding, the price will be fixed. So I think there will be more development, or more the trial and error will be done, and then it will be better into the future. Now I'm coming to the cost overrun study, finished with the Japanese information, but it is also relevant to you. This is a very famous study done by OECD IEA, and then it is called, is it written somewhere? Unlocking Reductions in the Construction Costs of Nuclear, a Practical Guide to Stakeholders, but it is called Red Cost report. And it is very famous, it seems, and I studied this time, but French reactor, Flamanville number 3, and Taishan, which is a Chinese reactor, they are using the same technology. European pressure reactor, is it called EPR? And yet, the overnight cost, which is not including the interest rate cost, the construction cost is much higher for Flamanville, and it is actually the factor analysis that which factor has caused that much higher expense than the Chinese one, and then it is like the project management, because it's first of a kind for France, and then the regulatory changes, and then the delays, and all these factors actually, well, I cannot say contribute, were the causes of the delay and then also the increased cost. And it was initiated by the question that why the Flamanville is so expensive and it took so long, even though it was after the successful it was after the Finnish reactor, which also took long, and yet they could have learned something from the Finland experience. So this one is to show that that's a big difference. And then the IEA went on to give us the recommendation later. This is the plotting of different reactors, which was constructed in advanced countries, and initial estimate of how many years it will be required for construction is around 5 years. But then Flamanville number 3 took 16 years. So it was kind of a very much longer time than they expected at the beginning or at the time of planning. And then that was following the Finnish one, I cannot read it, Olkiluoto number 3, which was also taking a very, very long time, even though the cost overrun is not that much as a Flamanville. France could have learned from the Finnish experience, but it didn't seem happen. But it's not the only one. The Vogel in the US is twice the 5 years expectation, 10 years. Hinkley Point was also longer. It's still ongoing. Therefore, why is that? That was the motivation for the IEA to run the study. And then it is, sorry, this is again very small. You have to read later, and I have to look at my notes. But in the United States, it was the, after 3 Mile, 35 years, for the first time in 35 years of new build, Vogel 3 and 4. And by then, there are industries which used to supply all these important materials and machineries and everything, have really decreased in number. Therefore, they have to import major the supplies from abroad, like Korea or Japan. And that was one thing which happened to the Vogel. And the number of the companies which have the called N stamp, which is the certification to be able to supply to the nuclear power plants, the number of these companies have reduced from 600 companies down to 200 from 1980 to 2007. It is a very 1/3 of the number. Therefore, they couldn't really develop the major materials for the nuclear power by themselves. That is actually recognized by the DOE, and then they expressed the concern. So everything which is most important is the lead, the power pressure containers. The lead is the most important to put the pressure on, was also have to come from the overseas. So it took 8 years, and then the cost overrun actually was $19 billion. It was more than $19 billion more than expected. So the similar thing happened for the French. French, their materials are all domestic, and yet there was some failure, so they have to patch it up, and then it took longer. And the core catcher was the talk of the town, I remember. But it took much longer than the French government expected. And then of course, the cost overrun was also big. England is another example. They cannot afford any material domestically, so they are fully dependent on the overseas companies. So they are still. There are many examples like that, and then of concern, the supply chain. There will be some talk in the afternoon. Maintaining the supply chain is very important. So here is this is also shocking. This is how many years it took to construct the new build, and then the top countries are Pakistan, China, UAE, kind of new countries. Maybe Estonia will join there, but this is the bigger, the light water reactors mainly. And China, as I have already mentioned, they had a very good record of constructing the reactors after reactors, and that helped them. They have the supply chain, and therefore it is shocking for us, but it's also the learning piece of information. So what went wrong with Flamanville? The Mr. Folt's report is very famous, so you may have been all aware of it, so I don't want to spend too much time on this, but it is factor by factor, what is the reason and what can be done list. For example, like a design change in the middle of construction is very bad, right? So complete the design before construction begins. It sounds very, how to say, natural, and it sounds very 当たり前ってなんでしょうね. It's a common sense. It appeals to our common sense, but in the middle of turmoil of constructing something and something went wrong, it happens. Therefore, I think what we have to learn from this report is that don't underestimate. This is a 1 century long journey, and then we have to be very well prepared. And I am relieved a little bit because of my previous speakers. They are taking step by step, and then they're concerned about the political issues or energy or issues, etc. So they are very well informed, but please try to observe the basic. And then these 3 slides coming on will tell you what are the basic things that you have to bear in mind. The introduction of innovative technologies also, it is because the regulatory requirement is different for the new technologies. And if you are not ready to inform the regulatory board that what is new and what can be actually exempted from the current regulatory standard, it can take longer than you imagine. The small module reactor is not the exception. There is no standard yet available in the world. Therefore, you have to be ready. You may become the leader of the world if you manage to put it ready. 8:45. Okay. The quality assurance as a nuclear energy standard, that is actually to inform the suppliers. Suppliers have to be ready also. What are the safety measures, safety standards, which are required for the technology they are applying? So that kind of communication and dialogue is very important in early stage information sharing, and also work together to develop, if it's necessary, the new standard. The project management, supply chain capabilities, I have already mentioned it, but it's very often happen. It often happens that the deviation from the specification originally planned. And then project management is very important. There is a series of decision making, and then you have to be ready as a whole industry to address that. If there is any change, you get stuck and then panic, and then you cannot do anything, and then you don't know where to talk to. It's no good. It's not ideal. So you have to establish the good communication, and then the information sharing early stage will be also good for this project management thing. Appropriate strategy planning for material procurement, that is also part of the supply chain issue. The third one, this is the third and last, and very difficult actually. The policy support. It seems currently the Estonian situation is very good, but in Japan we still have to worry about it. The political, the instability is no good for the healthy development of a nuclear, but still agreement on the use of nuclear energy at the national and regional levels are basic. And of course, that involves the public understanding. Without it, we cannot develop nuclear. And licensing framework or the funding, that is actually very important, but it will come into the, the next stage for the Estonia, but the funding for us, it's very important. How to fund the nuclear is still to be discussed. So somehow I feel that we are behind Estonia, but still those basic the points we would like to observe as well in Japan. So there are 8 drivers to reduce the construction cost. And then I think that will be almost a very good repetition of what I have said learning from the Flambeer. Therefore, I will skip all these slides coming up, but I would like to point out that back in 70s, 80s, Japan was doing very well because in relation to these 8 points, to keep the supply chain and everybody is developing the same thing at the same time, and then the construction period was as planned and then very short, and then the construction cost overrun was never happened, etc., etc. This is actually the Hitachi's history of their reactor development. And then you can see from the 1970s something, it's very punctually increasing over time. At the same time point, there are many reactors being constructed. That means, and then Hitachi is not the only vendor. There are many, 2 others especially, and then they are all doing the same all over Japan. Therefore, the end result was 54 reactors at the year of 2010. That is a very good learning point. That we have especially the 1980s, everywhere, anywhere, everybody was constructing the reactor, and utilities are very busy doing this documentation to apply for the permission, and vendors and suppliers are busy supplying and maintaining or the fixing the parts, etc. So it was a daily job. And the fund was readily available because banks had no concern about funding all these reactors because it was a kind of a daily routine kind of thing, and then they are sure that it will be returned. The cost comparison is a little bit complicated to look, so I hope that you will have a time to look at it later. But Japan has been doing very well. I cannot point it, but the green part, Japan, although the Japan is very high, the lower part, the green points were Japan. The France was also doing much well in the older time, but then the USA has a kind of variety after the 3 Mile Island accident. India, South Korea are also doing very well. So therefore, it is possible to maintain the cost at the same similar level if the construction period doesn't go too long. The right-hand side is Japan's blow-up, which was actually the less than 3,000 euro, I think. But that was back in 2011 money. So it is the checklist that what we have been doing well in terms of the checkpoint, 8 checkpoints. We have been doing all these things very well during the 80s. Therefore, we had a very much, IEEE never called it the golden age of nuclear for Japan, but it was a golden age of nuclear for Japan back in 1980s. Well, I am not saying that you have to have the 54 reactors, but you have to have the supply chain and then the multiple suppliers which are ready to kick in when one supplier cannot do it. So I will leave these slides with you because it is too time consuming. But as of 2020, we practiced all the key points for controlling the cost overrun pointed out in the NAIR's red cost report. And then it is worth studying, and it is worth talking to the people from Japan with their experience and the supplying technologies. This is something extra. Light water reactor is so popular in the world, and why is that? Is my colleague Murakami Tomoko's study, which is based on the data from the World Nuclear Society, World Association of Nuclear. It was actually since the late 60s that the light water reactors have started to take place. And then it was starting from the United States, and then it became worldwide. The red dots are the light water reactors, and then the blue dots are others. So you can see that slowly the red dots took over the other the reactors. And why is that? Is because it is standardized, and then there are the shared technologies, and then also it is abundant everywhere. You can actually learn from the US and to start your own industry. That kind of experience is rich in Japan. Once you have had that industry within your wing, and then you can keep on doing it. That kind of circle went very well for the light water reactors. The Murakami-san has her own theory that maybe it is as simple as just a combination of water and stainless steel. I don't know about from the technical point of view, but it is good for the general purpose, all these materials. Therefore, the suppliers to, give a twitch, more safety, the strength, etc., they can develop from their general use materials into the nuclear specific materials. That was also very important, I think, in many countries. So therefore, we are going for the light water reactors at the moment. But before we jump into conclusion, this is a person who is on the subcommittee. He's sitting next to me, and then his insight is sometimes very important because he, in general, speaks about anti-nuclear comments. And yet, it is very important to have the command center for the future technologies. If nobody says, nobody leads the exercise, everybody is dreaming about their own different dreams, and nothing will actually take place. So the communication and also have the actual plan and then the leadership is important. I think that is the takeaway from his messages. Even though in general we really worry about what he says, it is like the how to say one leading example of NGO, but still it is worth listening to what he says. US DoD is doing this project called Pele, Project Pele, and that is a small modular reactor. And it is encouraging because the Ministry of Defense is doing that kind of investment, and then it is supposed to have the starting in the 2020 at the Idaho National Laboratory. So keep watching. This is important, I think. So at the end, it is very important to have the construction within the time period you have planned and try to avoid the cost overrun. And the standardized reactor seems to be workable. Because then you can actually use the same modular for any other the reactors, and then you may be benefiting other countries who are following Estonia. It also is a very important thing to establish the supply chain, which includes the people, engineers, the young people. Young nuclear engineers should get into the field because, as I said at the beginning, it is a one-century journey. And then we have to be responsible until the decommission is done and spent fuels. I don't know about SMR, but for us, the spent fuels are safely locked underground. Okay. I am running out of time, so I just show this slide and then I end this. We have a good news. The Kansai Electric Power has announced that they will start studying, planning the new nuclear power station where they commissioned one old power plant. That one old power plant is very memorial one for them, which supplied the first nuclear power in Japan and to the Osaka Expo site in the first Expo in Osaka 1970. So we were very pleasantly shocked that the Kansai Electric Power has made the first step forward. It's nothing definitive, and yet that requires a college for them to be the first. But anyway, it's happening in Japan, so we are following Estonia very closely. So thank you very much for your attention. The conclusion is actually the sum up of what I have said. So I welcome your question.